Hello everyone, welcome to the explanation. So in last video we started our topic serializability in DBMS, in which we covered the two topics, that is what is a serial schedule and what is a non-serial schedule. So this will be part 2 of the topic serializability in DBMS. So in this part I will be discussing about the definition along with the types of serializability with examples. Okay, so what is a serializability and what does it do? Okay, so this concept basically came into light after we discussed about the concurrent transaction. What is concurrent? Concurrent transaction means the transaction which occurs concurrently, simultaneously. Okay, so in this context we can have a parallel schedule as well as a serial schedule. So if we have a serial schedule, there will be no issue because one transaction is going to happen after the another. But what happens in parallel or non-serial schedule, the transactions are concurrent. It means that if this is happening at the same time, some other transaction is going to be happen. So in this type of context we get a problem which can be concurrency problem. Okay, so let's start with the definition of serializability. So what is serializability? Serializability is the concept as it guarantees that the outcome of executing multiple transaction concurrently is the same as if those transactions were executed serially, one after another. Okay, so let's understand what is this. So what is serializability? It guarantees that the outcome of executing multiple transactions concurrently. It means that if this is a transaction T1 and this is a transaction T2, suppose read operation is happening here, at the same time we have to switch to this, that is to write operation. Again we have to switch to this for write operation. Again we have to switch to this for read operation. It means that simultaneously there are two transactions that is happening at the same time. Okay, so what does serializability tells? It tells that we have to experience that as if these two transactions are executed serially. So what is serially? Okay, so if you convert these two transaction into serial transaction, it is going to be looking like this. For example, first of all read will happen, then write will happen, after that write will happen and read will happen. So basically this is a serial schedule. So serializability, what does it tell is, if there is any two transaction which is two or more than two transaction which is happening concurrently, so we can have a corresponding serial schedule for that. Okay, so it should be same as these transactions are occurring in a serial way. Okay, so this is basically one of the concept of serializability. So here we have to perform some operations, we have to do some example. There are some rules using which you can convert this schedule into a serial schedule, or we can check that whether a transaction is convertible into a serial schedule. Okay, so let us discuss some more about this point. So it means that when non-serial schedules allow for concurrency, it means that they are non-serial schedules and we are going to and it is going to for concurrency, they need to be managed to ensure that they are serializable. Okay, so just remember one thing, serializable means that the schedule which can be converted into a serial schedule. Okay, it means that any number of transactions that is occurring, if even it is a non-serial schedule, there should be an equivalent serial schedule for this, and this is known as serializability. Or in a simple language we can tell that the conversion of a non-serial schedule to a serial schedule is known as serializability. Okay, so there is always a equivalent serial schedule related to a non-serial schedule. Okay, in order to ensure this, in order to achieve this, we have got two types of serializability. So first one is conflict serializability and second one is view serializability. Okay, so before going to each type of serializability, let us learn about some concept regarding to this. So for example, here suppose here we have three transactions. This is just some concept in order to solve the problem. Suppose we have got three transactions in a schedule. Okay, so there are three transactions. So here if I'll write like this, read of A. So what is A? A can be any data type in which read operation is occurring. W of A, read of B, W of B, and write of B. So okay, so can you tell me which type of schedule is this? Yes, so of course this is a non-serial schedule, because you can see here from T2 we are going to T3, again we are coming back to T2, we are going to T1, we are coming back to T2. It means that it is a non-serial transactions. Okay, so what are the possibilities, like in which order they can occur? So for example, we have got three transactions, so the number of possibility will be 3 factorial, which is equals to 6. It means that there can be three way of arranging this transaction. For example, first of all, we can T1 will occur, then T2 will occur, then T3 will occur. Second possibility is T1 will occur, T3 will occur, T2 will occur. Third possibility is first of all T2 will occur, then T3 will occur, then T1 will occur. So what is this occurrence? This means that this is a kind of serial schedule. Like first of all T1 will occur, it will end. After that T2 will occur, it will end, and after that T3 will occur. So there is no conflict here, no issues here. So in similar way, for these three transactions, we'll have 6 possibility of this. Okay, so T2 will occur, T1 will occur, and T3 will occur, T3 will occur, T1 will occur, and T2 will occur, and finally T3 will occur, T2 will occur, and T1 will occur. So from these possibilities, if you are going to convert this non-serial schedule into a serial schedule, so from this possibility we are going to get any one possibility which we don't know. Okay, so as we discussed in previous video, if it is a serial schedule, the graph will be, or the possibility will be like this. If it is a non-serial schedule, what will happen? There will always be a loop. Yes, so in order to solve, in order to convert this non-serial to a serial, we are going to follow some rules. Okay, so before discussing about what is a conflict serializability, we have to discuss about what is a conflict equivalent. What is a conflict equivalent? Okay, so two schedules are said to be conflict equivalent when one can be transformed into another by swapping. Remember this word, swapping non-conflicting operations. Okay, so there are certain words which we need to understand. It is said to be a conflict equivalent when one can be transferred, one schedule can be transformed into another. It means that we have to make a mirror copy of the another schedule. For example, if there is a schedule having two transactions T1 and T2 and having an operation RA, WA, RA, WA, and RB, and there is another schedule S dash which is also having two transactions T1 and T2 having operations RA, WA, RB, RA, and WA. So if we can transform this schedule into this schedule by swapping the non-conflicting operation, if we can make this schedule equivalent to this schedule, it is called conflict equivalent, and it is denoted by S triple equals to S dash. It means that this both schedule are conflict equivalent. It means that by swapping certain operations, we can convert one schedule into another schedule. So before going to the question part, let us see what are the non-conflict operations. Okay, so what are the non-conflict operations? Okay, so let us take two schedule, above schedule only, S and S dash, having two transaction T1 and T2, and it has got RA, WA, and RB. Here also we have got RA, WA, RB, RA and WA. So what are the non-conflict schedule? For example, in these two transaction, we have got a pair. For example, read operation on A, and another transaction is also going to do read operation on A. So if we are going to read any value, is there anything we are going to change? No, there is nothing we need to change here, because read operation, it doesn't perform any conflict, because the datas are not going to change. Therefore this pair is called a non-conflict operation, non-conflict pair we can say. Okay, so next is, if you are going to perform read on this data A, and at the same time you are going to perform write on this data A, is this a conflicting pair? Yes, this will cause a conflict, because someone is reading the data A, at the same time someone is writing at the data A. It is a conflicting pair. Similarly, if you are going to write in data A first, at the same time second transaction there is a read in data A, is this a conflicting pair? Yes, this is a conflicting pair. See, I am talking about this. In a same schedule there are two transactions, so somewhere read is happening, at the same time if write is happening, is this a conflicting pair? Like that we have to see. Okay, the fourth one is write at A, and at the second transaction also we are going to write. It means that both the transactions are trying to write at A. Is this a conflicting pair? Yes, this is a conflicting pair. Okay, now let's see other combinations. So here I'll write. Okay, so for example, if we are going to perform read at B and other transaction is going to perform read at A, is this a conflicting pair? No, because the datas are different. See, first one is B, second one is A. No, it is not a conflicting pair. If you are going to perform write at B and read at A, is it a conflicting pair? No. If the datas are different, whether you perform write, whether you perform read, it doesn't matter. Next one is read at B, write at A. No, it is not a conflicting pair. At the end, write at A and write at B. Is the conflicting pair? No, it is not a conflicting pair. Okay, now I hope you are understanding this. Now let us see what are the conflicting pair. So in a summary we can write that for a read operation, the conflicting pair will be write operation. Okay, for a write operation, the conflicting pair will be both read operation and write operation. This is the rule. If it is a read operation, the conflicting pair will be write. But if it is write operation, the conflicting pair will be both read and write. If you are reading also, it is going to do the conflict here. If you are writing also, it is going to do the conflict here. So this is the rule. Okay, so I'll start with a question, and then slowly we are going to the conflict serializability. Okay, so let us start with the question. So the question is, this is a very important question. The question is, find whether the following schedule are conflict equivalent or not. We have to find whether the following, it means the given schedule, is conflict equivalent or not. So the first schedule is this one, and the second schedule S dash is this one, where we have got two transactions T1 and T2. Here also we have got two transactions T1 and T2. In T1 we have got read of A write of A, read of A, write of A, and finally read of B. In second, we have got read of A, write of A, read of B, read of A, and write of A. So we have to check that whether S is conflict equivalent to S dash. Okay, so what I told you, you have to check the adjacent non-conflict pair in S and swap it. For example, if you want to convert this to this one, you have to only work for this. No need to work on this because you are going to convert this S schedule to S dash schedule. That's why we are going to see only this schedule. So what I told you, what is the rule? You have to check for adjacent non-conflict pair. We have to check for non-adjacent conflict pair and swap it. Okay, so I hope you have noted the non-conflict pair rules that I told you in last like previous section, here only in this video only. So what are the non-conflict pair? Let us see. So in this, here there is adjacent for any adjacent pair for this RA? No. Let's go to this WA and RA. Okay, are these non-conflict pair? No, they are the conflicting pair, WA and RU. If you see the combination, just scroll previous like a few minutes ago and you can see WA and RA, they are conflict pair because on the same data you're going to perform write and read, so it will not happen. Let's see any other adjacent pair. Is there any adjacent pair for this? No, there is no adjacent pair. Adjacent means this, like this. Okay, there is no adjacent pair for this. Now check this too. Okay, is this adjacent pair? Yes, they are adjacent pair. And are they non-conflict? WA, RB, yes, because as I told you, if you encounter two different data like A and B, any operation is happening, it doesn't matter, they will come under the non-conflict pair. So they are the non-conflict pair. So you check this and then you swap them. Swapping means you don't have to bring this here and this there. No, you are just going to swapping the position. You are just going to swap the position. Okay, you are just going to swap the position. So here, what we'll do, we are going to just swap the position. So I am just searching for the space. Shall I write here? Okay, I'm writing here. So what will happen? After swapping T1 and T2, after swapping this, what will happen? We are going to get RA as it is, WA as it is, RA as it is here, and after swapping, what will happen? RB will come above, RB will come here, and WBA will come there. It is just going to swap the position. See, RB came in the alignment of WA and WA went to the alignment of RB. Fine, that's okay. Now again check for the non-conflict here. So adjacent, is there any adjacent operation for this? No. Any adjacent for this? No. See? Okay. And are they okay, this is the adjacent, but are they non-conflict? No, they are conflict because read and write operation, it is performed on the same data. This is a conflict pair, so we cannot swap this. Let's check this one. Is this an adjacent pair? Yes. And are they non-conflict? Yes, it is a non-conflict pair. Yes, can you see this? Okay, now finally we are going to convert again, swap this and convert it to a new transaction. So let me draw a line for this. Where shall I write? I'll just erase this. Okay, I hope you have written this. I'll just erase this. So let us draw the final transaction here. So again it is going to contain T1 and T2, and after swapping, what will be the result? RA as it is, W as it is, and after swapping, what will happen? RB will come in this position, that is RB will come in this position, RA will go in this position, and WA is going to this position. Now this is our S schedule. If you check the S dash schedule, which is here, you can see RA WA RB, RA WA, RA WA RB, RA WA. So see, after swapping the non-conflict pair, we have changed this S schedule to S dash schedule. It means that S is conflict equivalent to S dash, hence proved. Okay, so this is about conflict equivalent. So after doing this, after solving this problem, we can finally do the numerical for conflict serializability. So for that, I'll be making another video because this video has already become too long. So till then, stay safe and thank you.